the channel. I'm Mr. Sensible. Today we're going to have a look at a channel suggested by one of the commenters to one of my videos. Unfortunately, having jotted down their name, I've misplaced it, so I'm very sorry, but big thanks to you. Before we proceed, also big thanks to my patrons. I greatly appreciate all my patrons, including new patrons TC Lucas, David Cooley, Blair Sadovitz, Brian Rulke, John Stock, Mike Apple, Jason Downing, Lucky Jack Aubrey, Duranku and Peter Lennox, and my newest patrons Critical Analysis, Justin Neal, Mark Adrisioko, Tom C, John Tomchik and Paul Emro. So we're going to look at Peter and Pete. That pair of idiots that think air is an element and that oxygen has to be manufactured and that gravity isn't a thing. Today they're going to run an experiment that will seal the deal about how objects fall. I think we better let them get on with it. Peter and Pete, roll VT. Can you just get on with it, please?
There you go. Well, this is the last time that we're going to be doing this because gravity's getting us down, obviously, you know, all of that weight upon us, you know, it's on my shoulders, you know, and talking to these globies and these people who dream an awful lot, kind of like does wear you out, kind of like gets tiring.
Yeah, it gets really tiring debunking you fools every day.
So we're going to do one more demonstration and this should seal the deal.
And Pete, or Peter, whichever one he is correct. This will seal the deal. It will show he's a complete gimboid.
Of course, so we've changed our setup. We're using white paper so objects can be seen better. What else have we done? We've reinforced, we put tape, duct tape, gaffer tape around the bottom there just to reinforce the plate at the bottom.
Right. High spec equipment. Gaffer tape for the win.
Because we are going to drop, and we've also placed our gauge closer to the tube, so it's more so we get a better indication of the lack of pressure inside the tube from the vacuum pump.
Hold on, you're going to try and pull a vacuum in that tube and the equipment is so rickety it needs to be reinforced with gaffer tape. What sort of vacuum do you think you're going to get?
So, and what the objects we're going to drop? The objects we're going to drop are these two here. We've done this before, but what we're going to do this time is we're going to drop one in air. We're going to drop them in air, and we're going to drop them in vacuum, because we were quite fortunate that our ball bearing, 30mm diameter ball bearing here, didn't cause any damage to our
brains,
our vacuum tube. So here we go, we've got 112.28 grams. That is phenomenal.
Yes, the amazing phenomena of an object weighing 112.28 grams.
Compared to this piece of silicate aerogel, we've painted it with a black pen, just so it can be seen better in the tube, and this gives us a ground weight of 0.17. Phenomenal.
Yet another phenomena. A light object weighing only 0.17 grams.
It's this shape, so what we're going to do is we are going to, if I find my cap, how we're going to do this is that we're going to place the silica aerogel there. This ball will touch the perspex, the plastic lid, because of the hole that's cut out, and we're going to hold it together with two magnets. Wait there, let's get a better view. we can see that the silica aerogel there is free to rotate around that ball. Let's try a test with air, and then we'll try a test in vacuum afterwards.
Well, Peter or Pete waffles around for a bit. I think it's quite clear. They've got the cap with the ball bearing on the inside, two magnets holding it. Between the ball bearing and the cap is that aerogel. Remove the magnets, they both drop. Going to try it first in air.
What we should expect to see is definitely the heavier object, the ball bearing, the 30mm diameter hardened steel ball bearing, hitting first, followed by the silica aerogel coming in second place.
Well, I don't think anybody would dispute that. Although actually having the aerogel above the ball bearing doesn't really give it much of a chance. What's it supposed to do? Muscle past? It would have been much better if you put the two objects side by side.
Because it's our view that objects do not fall at the same rate in vacuum, because objects fall at the same rate, objects fall at different rates due to their heaviness or their weight, not due to gravity, of course.
Well, Pedro there got himself a bit tongue-tied. What he's saying is that it's his opinion, or their opinion, that objects do not fall at the same rate due to the weight of their heaviness and nothing to do with gravity. You do know that weight is caused by gravity. Those objects have their own particular masses, but they only have the weights they've got right now because of gravity.
The force or the energy or the inertial mass lies within the object, and there is not an external force acting on objects as they fall.
So you're saying that those objects, when you remove the magnets, will of their own accord, without an external force, without gravity, of their own accord, they'll suddenly rush downwards. Why downwards? Why would they move at all?
Are we ready? Are we ready? Yes? Okay then, Peter, let's go.
Okay, come on Peter, before one of us dies.
3, 2, 1. There.
Well, I hope that was clear. The steel ball shot to the bottom of the tube, the aerogel fluttered more slowly down the tube. They will show slow-mo videos at the end. Something exciting to look forward to.
I want to be doing this again, that's for sure. So there we go, there's our...
So Peter Dunning, or Peter Kruger, whichever one he is, resets his experiment. The ball and the aerogel back at the top, and he prepares to make a vacuum.
I expect to see in this demonstration is the heavier object fall first, and at a much faster rate of fall over the 2 metre drop. So there's that, and that would mean that the reason why they fall is simply because of a property within the object.
No, Pete. The reason they fall, whether there's air in there or slightly lower pressure air, is gravity, not the object itself.
So let's switch the vacuum pump on. There we go. And we clearly see that the air is being evacuated from the system. There we go. Superb. It's going down. There we go. So the pressures, the vacuum gauge only go, or the vacuum gauge only goes up to, or it only goes down to -1 bar.
So not exactly a vacuum then.
A lot of them do. It's purely, I suppose, because you don't need to go any further down, do you? Because really 0 would indicate the presence of a vacuum.
So -1 indicates what? A negative vacuum?
The heavier object falls faster and hits the bottom first, in air and in vacuum. The only time you can get two objects to fall at the same rate is if you use identical objects, if you drop identical objects, or if you use a shorter height in which to drop two dissimilar objects to get the same effect of the two objects falling at the same rate.
No, 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 no. If you have a shorter height, it may be harder to measure the difference between them because they haven't had a chance to accelerate.
Obviously these are only our opinions that we're expressing through our demonstrations.
So you do a demonstration or an experiment so you can express an opinion. Surely, from your demonstration or your experiment, you should get measurable data.
If somebody says to me that they've got a fiver in their pocket, I'd like to see the fiver, then I know that they have got the fiver. I don't want to be wondering or dreaming, well, could they have the fiver? It's possible they could have the fiver, they might not have the fiver. I don't want to be like that. So, you understand where I'm coming from, don't you?
A nice room with padded walls where they give you jackets with really, really long sleeves?
Of course, yes.
Come on, your -1 bar must still be -1 bar. Can't we get on with it?
So on that note, I think we should get on and do the demonstration, should we not? Absolutely, are we ready? So again, what we should expect to see is the heavier object falling first, leaving behind the lighter object in vacuum, because the reason why objects fall...
If you say that crap one more time, I'm coming directly round your house with a rugby ball and I shall insert it up your left nostril, sideways. Now get on with it.
Let's switch the vacuum off and we're ready to go. Okay, 3, 2, 1. There.
At bleeding last, can we go now? Oh, you've got some results. I suppose we better have a look at that.
So let's have a little look at the
go on.
At the recordings of air, vacuum, and compare the two in slow motion.
Well, thank bleeding Nora for that.
Okay. There. Okay.
And in slow motion, he releases it, the ball goes shooting down, hits the bottom, and the air gel flutters slowly down. Good. Well, that was quite quick, but to my eye that looked quite different. Oh good, we're going to see this one in slow motion as well. And he releases it, the ball, oh look, the air gel's not far behind this time. That does look different. If only we had a comparison. Oh, okay. When he releases, the balls will hit about the same time. There, and the air gel, and the second air gel. Okay, we'll look at it a second time. When both balls hit, within a fraction of a second, the vacuum chamber below, you can see the air gel roughly a sheet and a half behind. And then you can comfortably go up to the top one and watch the one in the air slowly reach the bottom. Okay, 3, 2, 1. Okay, last time, and this time I'm going to pause it when both balls and the air gel in a vacuum are at the bottom. 3, 2, 1. Well, both balls hit the bottom very quickly, rebounded, and they've just come up to nearly a sheet high again. The aerogel in the vacuum passed the ball and is just about to hit the bottom. Look at the aerogel in the top. It hasn't even fallen 2 complete sheets. It's not even as far down as his elbow. It's moving much slower. I wonder why. Let's let it continue, and then Mr. Peter Dunning-Kruger, because I think he's double-barreled, can give us the explanation for this experiment. Cup of tea anyone while we wait for the gel to hit the bottom? No? Okay.
Well, there you go. That to me satisfies my my inquisitiveness, in that the heavier object hit the sponge, or hit the bottom first on both occasions, in air and in vacuum.
Yes. Are you implying that anyone suggested the sponge may hit first? As Jeranism would say. Interesting.
After looking at the video footage slowed down in air, the ball bearing actually just shot down, leaving the piece of silica aerogel way behind.
Yes, the gel was left way behind because it was affected by the air resistance, whereas the steel ball just pushed its way straight through the air.
And when we looked at the video footage of vacuum, we saw the ball bearing hit the sponge here, and the aerogel, the silica aerogel, was around this point here.
Wow, good work. You're not trying to fudge the data. All we need now is the conclusion.
So the distance was at least ½ a metre compared to when both objects left the cap at the...
Nearly ½ a metre.
Nearly ½ a metre, absolutely. Compared to the distance at the top of the tube. It's a clear indication that objects fall at different rates in vacuum. It's a clear indication that what causes objects to fall is something that is a property of the object and not an external force or influence acting on the object.
You've let us down, Pete. You've let us down big time. You've just shown yourself to be a smeg-headed gimboid.
So there you go. I mean, we don't need to do any more. It's all done and dusted. Thanks ever so much for all your comments that you've left. And now we can leave gravity behind and move on to better things.
Talk about disingenuous. You noted that in the air gel was left way, way behind. You then note that in the vacuum, the air gel was nearly ½ a metre behind. But you didn't point out the difference. In the vacuum, it was only ½ a metre behind. In the air, it was close on 2 metres behind. There is a difference. And the only difference between the two runs of the experiment is one had air and one supposedly didn't. That's your external influence. And the reason the air gel didn't keep up with the ball all the way down in the vacuum tube is it wasn't a vacuum. It was a lot lower pressure, but that equipment's not enough to pull a full hard vacuum. If you could make that vacuum rock hard, then they would have hit the bottom at exactly the same time. But even so, your noddy experiment with household equipment has demonstrated that with the much lower air pressure, the air gel almost keeps up with the steel ball. Now, you said it's all to do with the weight of the heaviness, or the heaviness of the weight of the inertial something that's inside the properties of the object, or some guff like that. But it was the same air gel and the same steel ball each time. So why did it behave differently? You idiot. Well, I hope everyone enjoyed that. Please join me again next time. If you haven't already, don't forget to like the video, share it with others, and subscribe. Just hit mini-me down in the corner. Oi, clear off, go away, silly person. Until next time, stay sensible.
Shut up and sit down.